Okay, we'll get started. Thank you everyone for joining us tonight. Tonight we have Michelle Strout. She is the Chapel Team Manager at HPE and a professor at the Department of Computer Science, University of Arizona. She got her PhD at the University of San Diego and was an assistant and associate professor at Colorado State University for many years. We're really pleased to have her tonight to answer all of your questions. And now I will hand it over to her.
All right. Thank you, Tanya. And thank you for inviting me. So I have only about 4 slides that just talk a little bit about some of the stuff I've done in compilers. And I do hope that you all will fill out the little questionnaire about whether you've taken compilers and whether it was required at your school, because I always find that's interesting. Okay, let me see. There we go. All right, so a little bit about me. As Tanya mentioned, I've been at various places. Where I got all my degrees was San Diego, very beautiful place to go to school. While I was a grad student, I actually had my first son, who is on the lower left here in the green and blue stripe. And you can kind of see him in the right. Now both of my guys are like 6 feet tall and essentially adults. So then did my postdoc in the Midwest. That's where I have my second son, the cutie pie to the right. Then spent about 10 years in Fort Collins. Spent some sabbatical in Australia. So I've got this cute little picture of a baby wombat. The adults are not nearly as cute, but a baby wombat and my son Zachary from our trip there. They actually went to public school there. That was very exciting. Was visiting faculty in Tokyo for 6 weeks at one point, and then I've been living in Tucson, Arizona since 2015. I've enjoyed being faculty here, but I've been on leave for a while, and I'm now work remotely for Hewlett-Packard Enterprise. So it's been nice. Computer science and compilers has given me the opportunity to live and work in lots of different places, and also raise a family. All right, so let me go to the next slide, which is learning compilers and assembly. So back in the 90s was when I was going to undergrad. And so the first class I took that like really captured my attention was CS30 at UC San Diego with Rick Ord. And we were learning how to do Spark assembly. And for me, you know, everybody's like, oh, it's so low level, it's such a pain, blah, blah, blah. But I really enjoyed the fact that it changed my whole perspective on computing in general. Because it's like, doesn't matter how high level programming language is, in the end, everything is going to execute at the assembly level on a computer, where you have to move data from one place to another, and then you have to take things in registers and add them together. And so, so this was kind of one of my biggest aha moments in my career. And then fortunately, at the time, UC San Diego actually required 2 whole quarters of compilers. So everybody had to take 20 weeks of compilers. And so I took one of those semesters with Gene Ferrante, who later ended up being my PhD advisor, and another quarter with Bill Griswold. And they were some of my most challenging courses, but also my most favorite, because you essentially saw how all of it works, like how you go from those higher level programming languages down to assembly, which is what everything has to go to eventually. And then I took 1 quarter of grad compilers with Brad Calder. And this was his first quarter as a faculty. And as many first term professors do, he was extremely ambitious in terms of what he had us doing. So I always talk about the fact that I saw my two partners in that class that I was doing a project with. I saw them way more than I saw my husband. And I would essentially be on the 7 a.m. bus to get into campus, and then on the 7 p.m. bus to get back. And I saw a third shift person like going to work and coming back. So for a whole quarter, but you know, that was really cool. So now I want to look at this questionnaire to see, now that I've talked about the compiler courses I took. So, so 8 of you have answered. So did you take a compilers course as a student? Looks like about 40% of you. And then was compilers required? Almost nobody had it required. Okay. In the pre-survey that we did, there was like a 1-to-1 correlation. People essentially only took it if they had to take it. But so it's nice to see there's more people took it because they got the chance to. All right, so then I got the opportunity to teach assembly code and compilers. And so while I was an undergrad, I was a teaching assistant for a couple of quarters for assembly, that assembly class. And then when I was a grad student, I got to be the head TA for the compilers course. And that was a really interesting semester because we were going from everybody learning C++ as their main language to Java. And so we had about 100 people in the compilers course, and about 50 people used Java, and about 50 people used C++ to write their compiler. And it taught me a lot, because the observation was the folks writing their compilers in Java, they didn't have to deal with memory management. And so they got their work done. They were not pulling the hours, the late hours in the lab, like the folks who were doing it in C++. So even though the TAs, we had written ours in C++, and so we could help a bit better because we were more familiar, those people who did Java, they still ended up working fewer hours. So I learned that lesson, and I took it along with me. So when I became faculty in 2005, and I started teaching compilers myself, mostly I had people implement the compiler in Java. And so I had to learn enough Java to do the reference compiler. But there was one time, the last time I taught compilers here at Arizona, I had everybody write the compiler in Haskell, and that was fun. That was a fun adventure for me and the students. And I've also taught grad level compilers a lot. So, you know, I really enjoy compilers. Oh, I want to tell you what the picture is. So these little Meggy Juniors, that's what this little device is called. And after I taught compilers myself, I think just one time, I was like, you know, it'd be more exciting if we were compiling down to an actual device that the students could, you know, run in a simulator most of the time, but then actually get to see a device do something. And so we found these Meggy Jr devices, and so they use AVR chips, and it's a pretty simple assembly code. And then I wrote a simulator to make sure the students could do everything on the computer if they wanted. And then we got all these kits and had people volunteer to like solder these things together. And we had a lot of fun with these devices over the years. All right. Also did a lot of research in compilers. My research area is compilers for high performance computing. So in a nutshell, myself and my group, we've looked at ways to optimize important scientific computations and look at how do we automate that using compiler technology. And so often what we're doing is we're looking at what are the kinds of things the scientists are doing or could be doing to improve the performance and the scalability of their computations. So things like atmospheric science simulations, I've done like small angle X-ray scattering, bioinformatics applications. We've looked at all kinds of stuff. And then we evaluate how the generated code does in terms of its efficiency compared to handwritten code. All right. And this is my last slide. So since January 2021, I've been managing the Chapel Parallel Programming Languages team at HPE. We've got about 16 people on the team right now. And the Chapel language has been developed starting in 2002 was when it started to be developed. The team has grown quite a bit recently. It's been a relatively small team for many years, but it's grown quite a bit. And I've always kept my eye on this team and this language because I've worked with a lot of scientists, and getting codes to run in a distributed environment where you have message passing interface, MPI, and then you're trying to get parallelism per node, and you're trying to deal with GPUs. It's a very complex landscape for scientists and engineers to navigate, and they essentially, for the most part, just want to do their science and get things to go. So I view Chapel as a pretty powerful tool. And I just got one little example there at the bottom of the slide where you can kind of see the core, some C++, MPI, OpenMP code that does this vector computation. And then in the middle, you see the Chapel code, which is much simpler. And then on the right, you see that we're getting the same performance. And so, so it's been really exciting working with that group. So with that, I will open things up for questions. I want to hear from all of you.
Thank you, Michelle. So if people want to turn their cameras on and ask a question, totally feel free to do that, or you can type in the chat and we can read it. I do have some questions that were submitted through the survey that I will be asking Michelle. And I can sort of start off with a few of those, and then if raise your hand if you want to ask a question if you're on the call. So that was a great background about yourself. And one of the questions that we had was, why did you decide to go to grad school and get a PhD?
Right. Well, I did it a really long time ago. My parents weren't able to pay for me to go to undergrad. And so when I went to school, they essentially said, you need to be an engineer, but we can't pay for you to go to school. And so I worked through undergrad, and then I started, and I was at UCSD for the second half of my undergrad, well, my last 3 years of a 5-year degree. I started interacting with people doing research, and I was like, oh, this is really exciting stuff. And then at some point, somebody's like, oh, they'll pay you to go to grad school. Right. And so I really enjoyed the university atmosphere. I enjoyed the people. I enjoyed working with people. I liked teaching. I had that experience as a teaching assistant. And so when people were like, oh, you could go to grad school, you could be a faculty, like you would be good at this. I just, did it, jumped in hook, line, and sinker. So these days, I think I would still make the same decision because I really did enjoy the faculty position. I am moving on from it now after 16 years, but it's a fantastic thing to do. These days, I think getting a PhD does open up some doors in terms of having a little bit more quickly being able to strategize about projects and lead projects. I think, and definitely if you want to be a faculty member, I think that that's important to get that PhD. But there's lots of different ways to contribute to compilers in computer science these days.
In one of your opening slides, you mentioned that you had, I think it was your first kid when you were first year of grad school. Is that right?
No, it was my, I had him at the end of my third year.
Okay. So we have a question submitted through the survey was, how do you manage your time between family responsibilities and a passion to pursue research?
Yeah, so that is not easy. No, yeah, it's not easy. It was, my first 3 years of grad school were kind of typical grad student. I'd go to coffee with my friends, we'd hang out. I mean, it was San Diego, it was beautiful, like occasionally we'd go to the beach on the weekends. And then I had my first son, and I did get childcare. Like, I took 4 months off, and I had a supportive spouse, and I think a supportive partner is pretty important. But then it was like, well, I was only comfortable having him in childcare for 6 hours a day. So for those 6 hours, I worked. There was no lunch. I mean, I ate, but there was no hanging out with friends. There was none of that. It was like just focused on getting it done. And it was a little less intense for the second one, just because by the time you have your second kid, you're like, yeah, you're going to survive. And so will I. We just have to get to the point where you're sleeping through the night. So it's not easy. I think you kind of need to build up a support, have a good partner, friends, and family that'll help. Helps a lot. And childcare, and when you can afford it, cleaners.
I think we have a question from Cindy.
Yeah, so thanks for sharing so much of your background. I was kind of interested to shift gears. I was interested when you talked about when you were in school, you learned compilers in an assembly language, and then you saw it kind of evolve into using higher level languages. And to me, I feel like that means that the emphasis in computer science education is kind of shifted into different fields and topics. And I was just kind of interested to see what kind of correlations and patterns that you've seen that have kind of evolved since you were in your undergrad, related to I guess kind of low level topics.
Yeah, that's pretty interesting. Yeah, my undergrad was a very systems oriented undergrad training that was happening at UC San Diego. There were some AI faculty in the department, and as a grad student, I think I took bioinformatics, but I didn't take any AI. Machine learning was not nearly as big. I'm not sure I even heard much about that. Maybe when I was a grad student, I heard a little bit about machine learning. It wasn't as big of a deal. Whereas, where we're at now in computer science departments is, I would say and I've been in 2 departments where we're bringing in grad students. I would say that about 2/3 of the grad applications that we see these days are people who want to do machine learning and AI type applications. And so there's been a pretty big shift. And I think that curriculums in computer science are trying to navigate that shift. You can only have people take so many required classes. And so how do you balance that? How do you help them get the statistics that's really going to help being more foundational for experimental computer science, but also for AI and machine learning? and, you know, some more of that math background that they're going to need for that, while still learning about all the layers. And in many cases, I think what we see these days is curriculums are starting to have kind of subspecialties and have people kind of specialize in different areas, which is one of the reasons probably why compilers has gone from being more required to being less required over time.
Yeah, it also kind of sounds like there's like a really high correlation with what people learn in school and what their general interests end up being like, you know, when they apply to grad schools and stuff. I was wondering if there's like kind of a causation in reverse, like undergraduate curriculums also have like they take into account what people are interested in industry and in research. Like, have you seen that?
Oh, have I seen undergrad? Well, I mean, academia moves really slow. It just does, right? If you look at the primary languages that are typically taught in computer science programs, right? It used to be C++ back in the early 90s, and then it was Java, and now it's like Python. But like I just mentioned 3 languages, but that's essentially like 3 decades. And so it takes a while. And I do think that faculty, you know, we do have industrial advisory boards, et cetera. And so we do listen to industry, but it's a slow process of what's happening. You know, and is that good? Is it bad? I'm not sure. I mean, there are some core concepts in computer science, like discrete math, that don't change that much. And there are a lot of shared concepts, although we still get the students every year that are like, discrete math, like, you don't need this to do computer science. It's like, okay, well, good luck with that.
It's funny you say that, because I heard a lot of kids when I was in undergrad say the same about operating systems. Like,
oh, really? Yeah. So I don't know if I answered your question at all, Cindy, but.
No, you definitely did. Thank you so much.
I can't pronounce your name. That is Kashiti, maybe? Do you want to ask your question, or?
Maybe a false hand raise.
Sorry, I dragged my mouse into a hot corner as I was trying to speak. It's my name's Kshitij, by the way. Yeah, the K is silent.
Oh, okay, Kshitij. Okay.
Yeah. Thank you for that introduction. And so I graduated from bachelor's around 4 years ago, and I'm considering going to grad school to like study compilers. I definitely do feel like I want to go to grad school, but I'm not sure whether I want to do research or not. So as someone who's like being on the other end, like you mentioned that you've taught compilers as a professor. What do professors look for in their like PhD candidates, especially like what if, I mean, some people have a very clear idea of what they want to what they want to focus on in the PhD, but how common is it for students to go for a PhD having like very little idea about what they really want to focus on?
I would say that that's more common than people knowing what they want to focus on. And the way that grad admissions works for the most part these days is most computer science departments, they're taking in all those applications. There is a committee that kind of does that first pass, that filter. But then then you'll get like a set of like, here are some applicants who mentioned your research, right? And so if you wanted to get into grad school, being able to list a couple of people, 2 or 3 people in the department that you'd be interested in doing research with and why is important. And if you show interest in like compilers or operating systems or databases or anything that's not machine learning and AI, then you're in good shape. I mean, that is going to help you, because like those of us who are not AI and machine learning faculty, we get very lonely around grad application season time, because you know, there's only like a handful of people that are like, oh yeah, I'd like to do research with you. I mean, I'm kidding a little bit, but not that much. So you know, if you in your statement of purpose, if you've looked at what's some of the research that people have done, and maybe even like download some of the software, tried it out, or just can point out like, I'm interested in this because of blah, then that would help. If you can go to school and get a master's, and you can get like a coursework only master's, you're going to have to pay for that, and then it's the focus is usually coursework. You know, it's a coursework only master's. But if you want to become a research assistant, then and that means get paid, not very much, but get paid enough to live on if you don't live in California, then you can you know, then you're going to have to do research, and so I don't think anybody knows that they want to do research before they actually like try it, and it can be frustrating. It's very different than courses. In courses, you know, we set up the assignments. The whole point, you know, sometimes there's hundreds of people in the class. We're not going to set up an assignment that we think you're going to fail at. Like, we want everybody to succeed, and we've kind of worked out some of the icky details to make things easier, and so that you can learn the concepts that we want you to learn. But it's well-trodden path. Like, these are concepts that we understand and we're trying to teach you in a classroom setting. When you're doing research, like, your advisor is going to kind of say, why don't we try this, or why don't we try that? And you're going to come back the next day and be like, well, that didn't work. And it, you know, it takes a while for you to realize, oh, my advisor doesn't even know quite what's going on here. And that's what research is. Like, you don't quite know what's going on, and you're trying to figure it out, and you're learning. There's approaches and ways of looking at the related research and trying out what other people have done. Like, there are ways of going about doing research, and your advisor can help you a lot with that. But research is there's dealing with the unknown, right? But as a hiring manager now, I actually ask references. How well does this person deal with the unknown? So research will give you that, that's for sure.
Thank you. I have one follow-up question. So how worth is it worth going for just like a plain master's without any thesis or research? Like, do you think you could, most of the stuff that you learn that you could like learn it on your own through online courses, or even like in a job working on an actual compiler?
That's really tough to answer. I mean, I think by the time you're taking grad courses, it's really a matter of where are you taking those courses? You know, what's the content in there? What are you going to get out of the interactions with the other people in the course? I think that some people do really well doing self-study and taking the classes on themselves. The last time I looked at numbers, and it's been like over 10 years since I've looked at numbers, the people that tend to do well in online courses are people who already have an undergrad degree. So they've already learned like how to study and how to learn things. And so if you feel like you can get a lot out of that, then I think that's great. There's so much going on in the open source community right now in terms of software development that you can actually learn quite a bit by starting to participate with some projects that are out there. So for example, there's LLVM and there's the Chapel programming language. You know, there's a lot of cool open source out there that is involving the development or the use of compiler technology. And so that can help get you a taste of it as well. And so I think I would recommend, I recommend to everybody, like really think about like, okay, what do I want to do? What are my goals? And if you want to be at a particular place, then start talking to people that are at that place if you can, and ask them like, okay, you know, what's it going to take? You know, what's it like? How can I get here?
That makes sense. Thank you.
Yeah.
I don't want to like hog your time, but if no one has a question, would you mind speaking a little bit about Chapel? Just like a brief description about its purpose, use cases.
Okay, so Chapel is a general purpose programming language. And the focus of it is to be able to write parallel programs. And I've been, over the past year and a half, I've been kind of coming up to speed and learning how to program in Chapel myself more. And it's actually really like fun to program in. There are some rough edges that we're working on, but it's a fun language. And the idea is that like, if you want a parallel loop, you just say like for all or for each. And then there's ways to, there's kind of default ways of distributing data across parallel machines. And then if you need to get in there and have more control over what's going on, there's abstractions and there's ways of doing that as well. And so we call it like multi-resolution programming. So you have this high level that people can, especially if you're starting out, you can just get something up and running pretty quickly. But then as you want to scale out to a larger cluster or larger machines, there are ways to have more control over where the data is being stored and how tasks are being scheduled.
Awesome, thank you.
Yeah, thank you for all the questions.
Michelle, I had a question for you. This is Anupama. So in your opinion, what do you think diverse teams bring to the table? And you know, to go into a little more detail about where this question is coming from, like in my experience working in the industry, and you know, as I've gotten more experience and have more experienced women, especially around me, I feel that there has been a gentle exodus of women from the core technical areas out to more peripheral technical areas. And so, you know, I'm kind of trying to understand, like, you know, how do, and some of the reasons stated are like, I think I have skills, but somehow, you know, I'm not fitting into a core technical role. I feel I'm not good enough and things like that. And so in your experience, both as an educator and now as a manager of a technical team, what are there some unique skills that we are bringing to the table as women that we should that should encourage us to, you know, stay in the path? And also, what are they?
And what are they? Okay, that's a really tough question, but it's a great one. And then it leads me to a joke that I would tell a lot as a faculty member. So there's this joke of like, you know, once you get a bachelor's, you think you know everything. Once you get a master's, you realize you don't know anything. And once you get a PhD, you realize neither does anybody else. And so, you know, this is super relevant, okay? Because look, there is a, in my personal opinion, there is a lot of ego in our field, okay? And I think most of the time it's ego trying to cover up like, oh, maybe I'm not good enough, right? And so then there's like some overcompensation going on and like maybe making other people feel like maybe they're not good enough. And it's like, okay, this is silly, right? Like the most productive thing I think anyone can bring to a team is to help raise up people who are around you, right? And so, you know, do women do that more than men? I don't know. I've seen all sorts of people who've been really good at raising up and helping others around them excel and learn things, and the people who are like comfortable with what they don't know. It's okay, right? Because if you ask questions, then you're always helping the other people in the class or the other people in the team, or you know, you're sharing a different perspective that people didn't think of. I'll give a concrete example of this that happened a couple months ago. We were actually in a customer meeting, and we were talking about some memory management strategies in Chapel. We've got this concept of like owned and shared, and it's a bit tricky, like to do like a linked list example. And one of the customers basically said, "Oh, why would anybody write their own linked list in Chapel? There's a list data structure." And it just dawned on me. It's like, I'm the one that's always telling the team, like, we're not trying to get other computer scientists to use Chapel. They can if they want, that's great. But we're trying to help out scientists who care more about their bioinformatics or their, you know, or their atmospheric sciences, or they're studying the astronomy. Like, they don't care about building a linked list, which happens to be like an important data structure thing that everybody in computer science is like, oh, I know how to build a linked list. And that's great. It's good that we can do that. But, you know, different perspectives really help when you're trying to make a product, solve problems, help others. You know, those different perspectives are crucial. And I know it's tough being a woman in this field. It is tough. It's really tough. And it's shocking to me that it's been tough for so many decades, and like, you keep hoping like, it's gonna get better. Like, it's gonna get better. It's gonna get better. And like, has it gotten better? Maybe, I don't know. You know, our percentages are finally starting to go back up again, but they were dropping as few as like 5 years ago still. So, you know, I know it's tough, hang in there. And I recommend just try to think about how you can help others around you, and realize that, yeah, you know, I don't know anything, but neither does anybody else.
I totally agree with what you're saying. The part where I get stuck is, I get different perspectives. I understand different perspectives in cultural issues and etc. Right? Like but when I'm sitting at a table and we're discussing a technical issue, what is different perspective? Sometimes I feel, okay, different perspective is just being able to say that this thing is too hard. This tool it's not intuitive, for example.
Right.
But it always feels like this different perspective that is sometimes being brought to the table is just, like inexperience. And, the questions that come out of it, genuine questions and good questions that can only be brought to the table if because you're looking at something through a pair of fresh eyes. But outside that, I mean, what is the different perspective? I mean, even if you have some examples of how a diverse team was able to solve a problem in a different way than a conventional team, it would probably help me kind of put my finger on it a little bit better and understand what is that thing that I should be valuing, which I'm not in terms of diversity.
Oh, interesting. Well, I mean, I think there have been studies that have shown that diverse teams lead to more profits and things like that. I think there are actual numbers behind that. I don't have I can't think of any examples that are popping to my head. I mean, I've taught classes where I'm the only woman in the class. Like, there has not been a lot of diversity in my career path. I shouldn't say that. When I was in grad school, we had a pretty awesome group of people. Yeah, like I was the first tenured female faculty member at University of Arizona in the computer science department. And to be there, I haven't seen a lot of it, but I think there are studies out there that may help if you're trying to make the. I'm not sure. I think, I don't know if you're trying to. It almost sounds like you think maybe we shouldn't worry about diversity in groups, or just consider it a solved problem, or
it's not that we shouldn't consider diversity. I'm thinking that are there elements in a team that we don't focus on? For example, during work from home, and I do not want to derail the conversation to this, so I'll keep this really short. So during work from home, for example, I guess I was one of the few people in my team who kind of missed seeing other people, right? And maybe as a diverse group, that is something I was bringing to the table, like saying, hey, being the person speaking up and saying that, hey, maybe we should meet and have some team events or something. And because it was becoming just about work and getting things done, and then but then some of these elements don't seem to be as incentivized, and they don't seem to be rewarded in a way. And so all this stuff that I felt I was bringing to, as in terms of team spirit, it felt like I was doing it because that's a part of my personality, but it's not something that I'm sure that is actually important. And so I'm just trying to understand what, how others feel about this. And as a as a manager of a compiler team and an educator, if you have seen that, there are, what are the, if there are other elements that kind of comprise this team spirit or whatever it is that, that can make it, I guess I'm going in circles. I'm sorry, but
no, that's quite all right. Like, actually, what you're referring to, well, what you're talking about, I tend to refer to as like hidden labor. So it's
I like that term.
Yeah, like trying to set up events for people on the team so that they get to know each other better, which does lead to more productive teams, right? Like we know it has a positive impact, but it doesn't always get recognized and rewarded. As a faculty member, this kind of hidden labor happens all the time. So there aren't usually a large percentage of women in undergrad computer science programs these days. We're lucky if there's like 20%. But when they run into problems, they come talk to the, 10% of the faculty, 10% of the faculty who are women, right? And we don't really get, like extra recognition or extra service points or anything for the time that we put into helping that group of students. I think there are a lot of pieces of hidden labor, being on hiring committees so that there's representation and things like that that makes things tough. And it would be easier, as you pointed out, if it was recognized.
Right.
Yeah. So if you're doing hidden labor type things, what I would recommend, and they're probably helping your team, is I would recommend you bring it up with your manager. Like, hey, I'm doing this, this, and this. Is this something that the company values? Can you say something about this in my review, my yearly review? Can it be recognized?
Right.
Yeah.
Makes sense. Thanks, Michelle.
Okay.
Any other questions?
I just kind of wanted to like echo what the conversation was about recently. Like I have another female coworker, and something that we talk about often. And there was actually like recently an article that I read that like kind of echoed this, and it's called like "No Reward or Recognition: Why Women Should Say No to Office Housework." And it was what we basically talk about is that like we've seen that women and other like minorities tend to like volunteer the most for like efforts that are maybe like tangential at most to like our described job position. And like while we really enjoy doing that work, it takes away our ability to like perform our actual job roles in a way that our male counterparts don't have. And I don't really know what the answer is in those cases, or like what the answer is, because ideally, like kind of like what Anupama was saying is that she enjoys being the person that's giving like that's kind of proposing team bonding like events, and I enjoy working on things that I think help like diversity and like getting more people involved, but I also enjoy doing my engineering work. And so I don't like, I think an easy answer from like a management perspective is like, oh, let's make time for both. But then, time is not infinite. So, and so I don't know if like you had thoughts on that as well. It's very like closely related to what Anupama was saying.
Yeah. And I think it's right. Time is not infinite. You have to realize that it is a zero-sum game. You've only got so many hours in the day. And so asking, having an honest conversation with your manager to try to understand, like, to what extent are they going to recognize that kind of labor? And, you know, that I think there are times when some of us want to volunteer and do these things because we're excited about it and it's important to us. And it's better going into it kind of knowing, like, to what extent is my management going to appreciate this or not? I think what's even more insidious, especially in academia, is the amount of request you get to do things like program committee meeting or program committees where you're reviewing lots of paper. So this is like volunteer work, not for your institution, but for the field in general. And it's a significant amount of volunteer work. And women get asked more because, you know, there's kind of, I think, the silver bullet approach of like, well, if we have a higher percentage of women on these committees, that's going to help the diversity of the conference. And my observation has actually been that it's the opposite. Like, we're now asking women to take on more of the reviewing load in the research community. And so, yeah, you have, like, let's say you have 35% women on your review committee, but then if you look at like who's actually publishing in your conference, it's less than 10% women. And it's like, well, maybe that's because we're spending all our time reviewing. And then you get the backlash when you say no. I've actually had people get angry at me because I have said no to workshops, and they're like, well, I need women. So can you give me you know, and then they give me more work to do. Like, you need to give me a list of women that can do this. And it's like, yeah, I don't think so. So I think, you know, this hidden labor issue is a significant problem in our field. And it's easy for me at the level that I'm at to, you know, at this point, I'm just like, nope. You know, I say no to almost everything. I don't say no to you all, but I pretty much say no to everything these days. And I take the opportunity, like when there are junior people that come to me and they say, you know, I'd really like to get on a program committee. I have my list. And then I ask them first, like, oh, so-and-so approached me. Do you want me to pass your name along? But I think it's wonderful that you're volunteering. I recommend for your own sake that you talk with your manager and find out how much they're going to appreciate it.
Yeah, thank you so much. I also thank you for sharing like that example about like the program committee like level of work. Something I'm interested, it sounds like you kind of have this like figured out now, but I guess how did you kind of come to figuring it out, and how did you navigate this like throughout your career?
Oh, so painful. When I was going up for tenure, I think the year before tenure. So when you go up for tenure, you have to get these outside letters, and they're one of the most important parts of your packet. And you give a list of names, and like maybe 3 or 4 of your letters will be from your list of names of people that you've picked out. But then your department comes up with a different list. And with just as many, if not more people on it. And you don't know who's going to be on that list. You can just kind of guess. And so if anybody in the community that year before you're going up asks you to be on a program committee, you just say yes, because like, I'm not going to turn it down. But I think I was on like 7 program committees, and this was back when they were in person. So you had all that travel on top of all the reviewing. And, you know, I had 2 small children at the time. And so that was a huge commitment. I think, so my sister is also a professor in computer science. And I think one year she was on 9 committees. And so I think what happened to me is after that happened, and after I got tenure, I was like, well, this has to change. Like, this is not a sustainable way of continuing to do research. Because while you're doing all that reviewing, like I said, you're not writing your own papers. And so I came to the realization that I was spending more time reviewing other people's papers than I was writing my own papers and doing my own research. And so I realized that I was prioritizing wrong. And I was just going to have to deal with the disappointment of saying no. Because women are asked more to do these kinds of things, that means we end up having to say no more. It's a double-edged sword. It's unfortunate. And then I started to become an advocate for more junior women faculty. And you know, I would have people that I was mentoring come to me and basically say, well, I've been asked to do this, this, and this, but I don't want to do it. And I would be like, then don't. Like, I would help, you know, kind of morally support them. Like, let's talk through, like, what's the benefit of doing it? What's the benefit of not doing it? And so it's okay. It's really okay to say no. And it's okay to bring awareness to this issue of hidden labor, and be talking with managers and try to open their eyes. And if you're not comfortable, maybe you can get an advocate to talk to management to try to work through this problem for you. Yeah, we have to quit pretending that it's not happening.
Yeah, thank you so much. I think something that, like, I guess we can all do is like definitely helping other people like not have to learn the hard way. And so I'll definitely keep that in mind. Yeah, thanks.
Yeah.
Yeah, sort of piggybacking on what Cindy was talking about, and you mentioned that you should talk to your manager about it. When you were saying that, running through my mind was like, how can we actually convince, you know, managers that this work is actually important? Because it feels like if we're the ones that are doing all the work, this hidden work, and we're the only ones talking about it, like how do you convince, you know, the people who are, you know, making promotion decisions and things like that, that they should be expanding their view on what they should consider, you know, what's important?
Well, so the approach I would take is more asking them, like, what are their thoughts about the benefits of these kinds of activities? You know, do they feel that these kinds of activities are beneficial to the team, to the company? And in what ways do you think that they're beneficial? Right. And then start asking them the questions like, okay, well, is our reward system, is our evaluation system set up to recognize the people that are making these kinds of activities possible? And if it's not, are there ways that you as a manager can work toward changing that? And it's, you know, I make it sound easy. It's much easier said than done, right? And one of the reasons why I'm recommending that you have an honest conversation with your manager is I think that sometimes you're gonna come to the realization that, okay, whoever is evaluating me, whether it's a faculty committee, because you get evaluated by your peers when you're faculty, like, or your department head or your manager, if they value this less, then I'm either going to have to decide to dial it back because I want to maximize how I'm being evaluated, or I have to just recognize that I'm going to be evaluated less because I really want to do this other stuff. And it's unfortunate, but if you have to kind of have a balance there, make a trade-off, it's better to go into it knowing what that trade-off is.
Makes sense.
Yeah.
Yeah. The thing is, the unfortunate truth is that even amongst my peers, I've seen other women turn down D&I opportunities, etc., because they know that that's not going to be incentivized, and they know that it's only the focus on whatever their technical contributions are that are going to be rewarded. And there's definitely fewer people who are choosing to spend their time. And it feels like there is a mold, and we're trying to conform to that, unfortunately, because sometimes it feels like a Herculean task to actually change the way workplace is viewed, or what is the right way a team has to be, what are the tasks that need to be incentivized or viewed.
Right. Well, and here's an example. I actually have an example where in academia, there are some concrete things being done that I think industry could learn from. And sometimes it goes the other way. But so the National Science Foundation, for 2 or 3 years now, has had this program as part of SCIES, which is the main computer science directorate, where if you're applying for a grant, you have to have a broadening participation in computing plan, period. Like, you're not going to get money from the National Science Foundation to do your research unless you are doing something to help broaden participation in computing. And there's been this big push to have computer science departments develop their own broadening participation in computing plans as departments, and then make it relatively easy for principal investigators, for faculty who are applying for grants, to participate in broadening participation in computing plans. But it's essentially a way of incentivizing, trying to help broadening participation in computing. And so, incentivization works. And so if companies are able to come to a realization that diversity and inclusion are important, having everybody on the team feel like they belong leads to more efficient teams that make more money, that, solve problems better, that, are happy. Then you get this like virtuous cycle going on. It's a good thing, and companies should. And so incentivizing those kinds of inclusion activities and broadening participation in computing, it actually makes financial sense for companies. And I think they'll get there eventually. I don't know if they'll ever get there, but I see small incremental improvements happening over time.
Are there any other questions?
Hi, Michelle. I want to change gears a little bit and go back to the questions I was asked earlier about applying for grad schools.
Okay.
What would be your views and advice for people who want to kind of switch from industry to research?
If you're coming from industry and you're going into grad school, I felt that was quite valuable. So my first PhD student had been in industry for 25 years before he decided to come back and get the PhD. And then like my third grad student had been in industry for 10 years before he'd come back to get the PhD. And so you're actually bringing a lot of valuable experience if you've been in industry into academia. And so just showing that you have that interest in learning how to do research and trying to learn how to ask questions. The hardest part of research is really how you pose the question, looking at, what are the important questions that we should be trying to answer, and what have other people tried, and how can I help solve this problem better than people have in the past? And, so showing that interest in research and in the research of particular faculty members. Like I said, 2 or 3, like specifically mentioning them in your statement of purpose is important. Another thing that does tend to be important is to have the background that a particular department is looking for in terms of coursework. And so there I would recommend actually, usually most departments have like an email address that potential grad students can send questions to. Well, first look at the webpage, because usually the webpage kind of gives you a lot of this information, but you can also ask questions to that email address of like, what kind of coursework. If they don't say what coursework they're looking for, you can go look it up. And if you're missing something, then but you already have a bachelor's or something like that, then maybe you want to take an online course to try to fill in some of those gaps.
Got it. But my question more is about, you are also in the pool with people who have had a lot more research experience, let's say in their undergrad or maybe master's. And like, I personally have a bachelor's and a master's, but I want to kind of go deeper. So, but I don't have a whole lot of research experience, but some industry experience. So what
right.
would
Well,
be-
so you talk about the experience you do have, like the experience in the projects that you're working on. And there's really 2 kinds of pools. Okay. There's the grad applicant pools that the top 20 places get. Okay. Your Stanfords, your Berkeleys, your MITs, your UC San Diego's, right? Like, UW, those programs, there's a ton of competition, but you go to the ranking, whatever rankings you're looking at, you look at lower ranked R1 universities that are still publishing in good places. For compilers, I would look at who's publishing in programming languages and design and implementation, PLDI. That's the main conference. Go see who's publishing there at PLDI and who's not at a top 20 school. and there, the applicant pool is very different. Like I said, the applicant pool, well, first of all, it's much smaller, and it's like 2/3 people who want to do machine learning and AI. So if you can find some people doing compilers research or programming languages research, at the level that you're interested in doing that kind of research, like PLDI, then, apply to those schools. Grad school is not about, a lot of people think it's about like where you go, and that does impact like who's around you and what kind of classes you're taking, and it does somewhat, but it's so much more about like who you're working for. Your advisor is, when you're getting a PhD, your advisor is that's the most important person. And so you want to kind of apply to a place where if it doesn't work out with your top pick advisor, like there's another person that you could potentially work with. But they're the one that's going to help you figure out this whole research thing and support you financially, support you in your training, support you when you're having a difficult time with life in grad school, and then when you're getting ready to graduate, they're going to help you get a job. And so that's an important thing to remember, is your advisor is important. And I recommend, there's like tons of schools that are not in the top 20, tons of them, like, I don't know, 50 or so that do good. There are good R1 research computer science departments that do lots of great research, and they just don't get the same applicant pools.
So is there a way to build some sort of research experience on the side that a lot of these schools do allow you to have maybe not paid internship, but some sort of like projects that you can approach the faculty for?
So that is a great question. Not like really officially, but definitely unofficially, I've seen people do things like where they've gotten interested in somebody's research and they've like read the papers and maybe they've downloaded the software and they've played around with it and they've tried some things. Maybe they added a little bit to the software or something, and then they start a conversation up. Usually if you try to email a professor cold, it doesn't work out so well. So I would although if you ask somebody about their research, that helps. But we get a lot of cold emails. I would recommend, finding that first author on the paper who's typically a grad student and sending an email to them and asking them a question about the research. And then if you can strike up a conversation with some of the grad students or the postdocs in the lab, and then ask like these days, like, hey, is there any way I can virtually join your research meeting and just hear what you all are working on? So I definitely would let undergrads at the institution I was at, like I had an open invitation at the beginning of every semester, like here's when my research group is meeting, here's the kind of stuff we're going to talk about. If you're an undergrad and you're interested, you can just come show up and just absorb and hear what's going on. And these days with virtual meetings, I mean, if you show some serious interest in what somebody's research group is doing, then you can always ask to see if you can come and listen to the talks and, kind of dive in. Because when you first start going to a research group meeting, it's like being thrown in the deep end, and I just tell everybody like, okay, just keep, just absorb, keep doggy paddling and ask questions and see what you think. And we'll try to help you navigate and learn what's going on.
Great, thank you. That's very helpful.
Yeah, good luck.
Thank you.
So we're kind of nearing the end here, but I did have one question that was sent to me in chat. Actually, it's a multi-part question.
Okay.
So I'll just kind of give you the 3 parts and you can pick where you want it, which ones you want to answer or can speak to. So the question is, can you share some thoughts on how to build a profile for teaching compilers as a side job, say in the summer? And then what options can one explore for adjunct teaching faculty positions? Do CS departments look out for such people in general, and what skills do they look while hiring? I feel like these are all sort of related, like building your skill set. Yeah.
Yeah. So hiring faculty right now is quite difficult. It was interesting coming into an industry position, and we've done a lot of hiring. I think we've hired about 8 or 9 people over the last year and a half. And we made one offer out of all those. We made like one offer where somebody turned us down, and people on the team were like, what? They turned us down? They went somewhere else? And I'm like, wow. Like in academia, I think the hit rate is like, I don't know, it seems so low to me, like definitely less than 50%. You make offer after offer after offer. And I'm talking tenure track faculty, and I'm talking teaching faculty as well, like lecturers, full-time lecturers. So a lot of departments are looking for lecturers, they're looking for adjuncts. Typically they're looking for at least a master's degree. And that's because sometimes universities can have these rules that like, you can't teach somebody unless you've got a higher degree than they do. So like if you have a master's degree, you can teach the undergrads. And if you want to teach the master's students, you have to have the PhD, that kind of thing. We actually have some weird rule like that here at U of A. But yeah, so the teaching faculty are about half and half master's and PhD here at U of A. And we have had some adjunct from industry, but we're a relatively small department. I think other departments have more adjuncts. And so if you're working in compilers in industry, and you're near a school that they're going to want you in person. If you're near a school, probably, maybe they'll let you do remote. It's not going to hurt to like contact the department head, right? Contact the department head, or the undergrad director is usually a faculty member, or maybe the undergrad coordinator. There's usually like some administrative people that help lead departments, and contact them and ask them if they have positions open. Usually their webpage will have like teaching positions open, and then they'll have like an email address if you have any questions, and you can ask. Like if it's a regular full-time lecturer position, you can send them email and say, I'm interested in an adjunct position, and here are some of your classes I see you've listed that I could teach, and here's why I think I could teach them. Like a real short little email that kind of summarizes how you think you could help their department, and then see where it goes. I mean, they're not just going to hire anybody on site. They're going to make you go through a whole interview process. You're going to have to like teach a lecture to usually a group of faculty, potentially with some students in there as well, to show that you can actually do it. And yeah, but it's definitely feasible these days.
Great, thank you. Are there any final questions before we thank Michelle? No? Okay, well, I want to thank you so much for participating in this Ask Me Anything. It's been fantastic. We've got a lot of great insight into different areas, and I definitely enjoyed it quite a bit. So thank you.
All right. Yeah, thank you, Tanya.
And one final bit before everyone drops off, I wanted to mention that next month, I believe it's June 30th, we will be having another speaker, Angelica Moria. I'm sorry if I said your last name wrong. She's a PhD fellow at Microsoft Research, and her research focuses on making software more performance efficient. And she's going to give a technical talk on her research, followed by a Q&A session. So please come back for that talk next month. All right, great. Thank you, everyone. And we'll see you next time.